Pascal's triangle. In this module, you will learn about Pascal's triangle. Look at these expansions. They represent the binomials raised to some power and their corresponding expansions. There are several things that you must have noticed after looking at these expansions. Firstly, the number of terms in every expansion is one more than the power of binomial. Secondly, the sum of indices of x and y in each term is equal to power of the binomial expression. Power of x begins with the power of binomial expression and decreases to 0 in the last term, and power of y begins with 0 and increases to the power of binomial in the end. If you remove the coefficients in these expansions, they form a triangular array. This triangle is known as the Pascal's triangle. Note that each row in the triangular array starts and ends with 1, while the rest of the elements in the triangle are equal to the sum of the two elements immediately above them in the previous row. Also, there is numerical symmetry in this triangular array. The number appearing on the left appears in a corresponding position on the right. Thus, we can complete a line of array by finding the first half of numbers in the array and then copying them in the reverse order for the rest of the places. On alternate rows, there is a middle number that is right in the middle and does not get repeated. Pascal's triangle, named after the French mathematician Blaise Pascal, is an easy way to find the coefficients of expansion for higher power of binomials. You can use the concept of combinations to represent the numbers in the Pascal's triangle. You can represent each element of the triangle by combination NCR when n is the index number and the value of r increases from 0 to n as you move from left to right in each row. Presence of 1 at the beginning and at the end of each row in the triangular array helps us to conclude that for any non-negative integer n, nc0 or n choose 0 is always equal to 1, and also ncn or n choose n is equal to 1. The symmetric pattern of Pascal's triangle helps us to deduce the result nck is equal to ncn minus k, where n is positive integer and k is non-negative integer. The fact that every binomial coefficient lying between first and last term is equal to the sum of the two elements immediately above it in the previous row helps us to derive the result n plus 1 ck is equal to nck plus nck minus 1, where n and k are positive integers. Now, look at the sum of binomial coefficients in each row of the Pascal's triangle. They can be represented as 2 raised to the power of the corresponding index number. This helps us to arrive at the result, which states that sum of binomial coefficients in a binomial expansion is given by 2 raised to the power n, where n is a non-negative integer. Observe that if you multiply every alternate binomial coefficient in any row of this triangle by -1, you get the sum of the binomial coefficients as 0 for all the rows except the first row. This helps you generalize that summation of minus 1 raised to the power k into nck for k varying from 0 to n is equal to 1 for n is equal to 0 and 0 for n greater than or equal to 1. The previous discussion helps to conclude that a plus b whole raised to power n will have n plus 1 terms. Coefficient of each term is NCR, where value of r increases from 0 to n as you move from first to the last term. The index number of a decreases from n to 0 and index number of b increases from 0 to n as you move from first to the last term. This is known as binomial theorem. The expansion of binomial theorem can also be represented as a plus b whole raised to the power n is equal to the summation of NCR a raised to the power n minus r into b raised to the power r, where value of r increases from 0 to n. Let us recall what you have learned in this module. Pascal's triangle is symmetric. Some of the properties of binomial coefficients are NC0 is equal to 1 and NCn is equal to 1 for n is equal to non-negative integer. NCk is equal to NCn minus k, where n is positive integer and k is non-negative integer, and n plus 1ck is equal to nck plus nck minus 1, where n and k are positive integers. The sum of binomial coefficients is given by summation nck, where k varies from 0 to n is equal to 2 raised to the power n. The alternating sum of the binomial coefficients is equal to 1 for n equal to 0 and 0 for n greater than or equal to 1. Binomial theorem states that if n is any non-negative integer, then binomial a plus b whole raised to the power n is equal to the summation of NCR a raised to the power n minus r into b raised to the power r, where value of r varies from 0 to n.